planet. And below it, and to the left, is a second. They both appear to orbit a star around 200 light years from the Earth. Just a decade ago, capturing an image like this through a telescope was unthinkable. But today, thanks to the ingenuity of astronomers like Ben, we have hundreds. And by analyzing the light from these distant worlds, scientists can work out their chemical composition and potentially the fingerprints of life.
At this point, we're studying much larger planets, gaseous things like Jupiter, that most likely don't have any kind of life like we know it. But that's a first step. And we're going to fainter and smaller planets as time goes on, as we develop this technology.
In the not-too-distant future, scientists may be able to simply scan a star for Earth-like planets and find the signature of life there.
We can look right at the light from a little planet around its distant star, and that opens up a whole range of possibilities for us to not just detect the planet, but to study the planet.
I mean, this all sounds like science fiction, but there is a reality to this. We have a scientific method to actually determine whether there is life on another planet.
Life is one thing, intelligent life, another altogether. That requires billions of years and a powerful force field like the one we owe our lives to every day. If an alien astronomer were to file a report on our home solar system, they might make a surprising observation. Because of all the 8 planets that orbit the Sun, they could easily conclude that 2, not 1, were suitable for life. It's an easy mistake to make, because the Sun has 2 planets within its Goldilocks zone, the Earth and Mars. Both planets have surfaces warm enough for liquid water to pool on. But while the Earth is blessed with warm, liquid oceans, Mars is dry and dead. The one crucial difference between these 2 planets could be the key to finding truly habitable exoplanets: a magnetic shield. Our Sun is constantly hurling deadly radiation out towards us. Only our magnetic shield, the magnetosphere, saves us. Without it, the solar wind would blow our atmosphere away. And without an atmosphere, liquid water could not exist on the surface.
In order to have liquid water, not only do you need the right temperature, but you need the right pressure. You know, if there were no atmosphere here right now, even at the same temperature we are today, all of the water would boil off into vapor immediately.
So where does the Earth's magnetosphere come from? And why doesn't Mars have one? Actually, in the past, both Earth and Mars had magnetospheres, but Mars lost its around 4 billion years ago, and with it, the potential for life. Both the Earth and Mars were born into a realm of violence. Asteroids smashed into their surfaces, turning rock and metal into a molten mass. As they started to cool, a solid crust formed on the surface. But the molten metal below churned as the planets turned, inducing a magnetic field which rose high up above the surface of both planets. At the same time, active volcanoes pumped gas into the space around each planet. Protected by the newly formed magnetic field, these gases built up into thick atmospheres, creating the air pressure for liquid water to run on the surface. For over 100 million years, both Mars and Earth were warm, wet paradises, primed for life to take off. Then, quite suddenly, Mars's magnetic protection disappeared. The solar wind blew its atmosphere into space, and its oceans boiled away, leaving the dry, sterile red rock we see today.
Mars' fundamental problem is that it's smaller than Earth. And because it's smaller, the internal core of Mars cooled down and solidified. And once it becomes a solid metal, there's no more magnetic field. The magnetic field shuts off, essentially, and the atmosphere, therefore, is vulnerable to both energy and radiation from the sun and the rest of the galaxy, and probably just blew off. Whatever life was on there, at least on the surface, is now completely exposed.
All rocky planets will one day lose their magnetospheres as their cores cool and turn solid. So, to know if an exoplanet is alive, you need to work out if its magnetosphere is still active. But magnetospheres are tough to measure because they are unbelievably weak.
The Earth has a magnetic field of approximately half a Gauss, which, when you think about it, is actually really weak. Our fridge magnets are about 100 Gauss, so they're much stronger.
Exoplanets are too far away for us to measure such weak magnetic fields directly. But there is an indirect method. When electrons in the solar wind interact with a planet's magnetosphere, they emit radio waves that beam out into space, turning the planet into a giant radio beacon. Astronomers like Evgenia hope to use these signals to spot habitable exoplanets. Not only that, the frequency of the signal should also tell her how big the planet is.
If we're looking for the magnetic signature in the radio waves of a giant planet, say a hot Jupiter, we expect it to have a strong magnetic field, and therefore it would have a high frequency, and around 100 megahertz, kind of where the limit of this radio is. However, a weaker field like Earth's requires us to go down to lower and lower frequencies. So instead of 100 megahertz, we go down to 10 megahertz.
But hunting for exoplanets at 10 megahertz presents a unique challenge. Because the Earth's own magnetosphere creates a deafening radio roar at that frequency. So to find alien Earths using radio requires a dish in space.
When we want to look for magnetospheres of extrasolar planets, we really need to get outside of the Earth-Moon system in order to get away from all the radio frequencies that are bouncing around the Earth.
With a slew of new technologies and upcoming technologies, scientists are edging ever closer to the ultimate prize, finding a second Earth.
I wouldn't be surprised if we have that data about an Earth and about life on it around another star in 10 or 15 years. I'm hoping to see that soon.
Using shadows, rainbows, and now radio, we finally have the tools to detect a planet just like our own. But in the rush to find the Earth's identical twin, are we missing something big? What if Earth is an outlier, a freakishly lucky place on the very fringes of habitability? Could there be another kind of planet out there, even better for life? For years, astronomers have scanned the heavens for planets that could sustain life. They've based their search on the Earth, seeking the exact same conditions and the exact same size.
I think right now there's a huge focus to finding Earth-like planets. Now, whether or not there actually is life there, that is another question altogether.
But after 20 years of searching for an Earth clone, the exoplanet hunters may be about to switch targets. Recent observations have revealed a brand new class of planet, and it's one that may eclipse our own home.
We've learned something in the last few years that really shocked us. With the Kepler Spaceborne Telescope, we have found hordes of planets that are a little bigger than the Earth. We never imagined that there would be such planets. In fact, in our